In this video, we will be solving practice questions on the application of exponential and logarithmic functions. So, um, in terms of the application, we have 1, 2, 3, 4, 5, basically 5 common applications that whereas wherein logarithmic and exponential functions are useful. So when it comes to compound interest, um, when tuition fees usually, I suppose that compound interest has a difference compared to appreciation in some way, although the formulas of their respective titles are quite similar. Let's be honest. A, B, A, O, 1 plus R, 1 plus R, except there is a divided by N. So yeah, they both have raised to T. T stands for time. So just so you know, in every formula, the T stands for time. So it could be in days, in hours, in minutes, years, months. It really depends on the statement problem, the problem statement. So let me dive in to each formula. So for compound interest, A sub t is our present amount, P would be our initial amount, and 1 plus R is the rate, either rate of increase or rate of decrease. But usually, rate of decrease goes for depreciation or decay since it's minus R. So for N stands for the interest compounded. So it could be annually. If it's annually, then N is 1. And if it's monthly, N is 12, since there are 12 months in 1 year. And if it's quarterly, N is equal to 4, I suppose, since there are 4 quarters in 1 year. So yeah, that's it. That's everything that you have to know when it comes to N. It's the interest compounded. And for years, for T, it's basically the number of years. If there's nothing specified, specifically when it comes to the unit of your time, I suppose that you know the unit of measurements when it comes to measuring kilometers, meters, that kind of stuff. Here, there's supposed to be a unit for time, for in hours, minutes. I think it's rest assured that each problem will provide a unit for your time. Otherwise, you don't have to specify a specific unit. For number 2, exponential growth, A is equal to AO e raised to KT. So A is basically our present amount. AO is our initial amount. E is basically Euler's number. It's a significant part of logarithmic and exponential functions, especially when you involve these in solving equations. K is basically constant proportion, if I'm not mistaken. You solve it provided that you have particular values. I'll be explaining that later. For T, again, it's the time, number of years, months, whatever that is. When it comes to appreciation, we have this kind of formula. It's basically the opposite of depreciation. The only difference is the plus and minus sign. So appreciation has a plus sign, depreciation or exponential decay has a negative sign. So when it comes to radioactive decay, we have this kind of formula. Personally, I did struggle in differentiating, provided you have a problem about decay. I'm not sure which formula to use, whether this one or this, but there is one clue that I've found so far. When the problem provides you a given of rate, when there is a word rate, then that means the formula is this one. It hasn't been 100% proven yet, but I think it works. It works just fine. If there's no mentioned rate, so that might suggest that this is the formula that we'll be using. And apart from that, what you have to know is that um, decay involves half-life. In order to solve for half-life, actually there is one formula that you have to take note of. Well, usually A and AO, the present and initial amount respectively, they aren't usually given specific values, especially when solving problems about decay. Something related to bacteria, microbes in particular, bacteria, algae, viruses, that kind of stuff. So A would be equal to 0.5 AO times AO. And in order to solve for K, or constant of proportion, it's basically ln times 0.5 divided by the half-life. So, I think I've mentioned everything already, everything that you have to know for these specific formulas. Let's proceed to solving problems. Let's practice. So we have a total of 12 questions for this video. We'll be solving 12 questions. Let's start with number 1. Suppose that the school's tuition fee is rising at the rate of 2.50% per year and that it continues to increase at this constant rate. So I think you can say that there is constant rate. It's a keyword. And rising at the rate of 2.50% per year. So for given, we have r is equal to 2.50%. Of course, the r is supposed to be in decimal form. So it will be 0.0250. So move decimal point to 2 places to the left. And hang on. So yeah, I think that's correct. Per year. So it suggests that our t is in years. It continues to increase at a constant rate. So it suggests, this phrase suggests that the problem is all about appreciation. Not literally, not the words like appreciate. Appreciation is the opposite of depreciation. The constant rise of something that is worth a price. For instance, the rise in tuition fees, that kind of stuff. It's pretty evident here. School's tuition fee is rising constantly. So there's a fixed rate. Let's take note that if the tuition fee is 150,000, this is, by the way, the currency is in Philippine pesos. We'll be sticking to with the currency Philippine pesos in this video. 150,000 pesos. That is our initial amount for now, since it asks in how many years will the tuition fee be 200,000 pesos. So the given suggests that our final amount is 200,000 pesos, provided that we have to find in how many years will the tuition fee be 200,000 pesos. So we are provided these variables already. Let's rewrite the formula of appreciation. So A is equal to P times the quantity 1 plus R raised to T. It's this one. So let's substitute. Let's give in the values. So 200,000 is equal to 150,000 times the quantity 1 plus R. R is 0.0250 raised to T. T is what we're trying to find. And just to prove the existence of exponential functions in this equation, I think I've already mentioned this before in the previous video, specifically about exponential functions. We know that an equation is, or an expression is, an exponential function if the exponent is a variable, or at least one of the exponents are variables. we know a polynomial function if the exponent is only a number or an integer, regardless of whether it's a negative or a positive integer. So anyways, let's proceed to solving. First, this is actually not an optional technique. You have to do this. It's mandatory. I've made my mistakes before. I did try to simplify this even before dividing, but it did confuse me more. I think it's less confusing if you divide both sides with the number beside the 1 plus r or 1 plus r over n. So cancel 1.0250 raised to t. I think that's it. And at the left side, 200,000 over 150,000. Let's try to simplify the fraction already, the improper fraction. It's basically 4 over 3. And I know that it's unlikely to divide both sides with that number. In order to bring down the variable exponent, we have to put logarithm or log on both sides. I'm just writing log here at the right side since it doesn't fit here. So in that sense, we have t log 1.0250 is equal to log times 4 over 3. Then divide both sides with this. So duplicate. So yeah, divide both sides with log 1.0250. Cancel. T is equal to, so log 4 over 3 over log 1.0250. The answer, 11.65053197. So let's try to round that off. So we have something like this, or in approximation, the answer is about 12 years. The question asks, to recall, the question asks, in how many years will the tuition fee be 200,000 pesos? So it would be after 12 years. So yeah, that's it for number 1. I'll give you 3 seconds to absorb what was taught just now. Alright, let's move on to number 2. A video posted on YouTube had initially 100 views, or initially had 100 views as soon as it was posted. The total number of views to date has been increasing exponentially. So I think it suggests about exponential growth. According to the exponential growth function, there. So it's pretty obvious already. Y is equal to 100 Euler's number raised to 0.2t. So let's just copy that. That's our given. So we write it that way, where t represents time measured in days since the video was posted. So how many days does it take until it creates 50,000 hits? So I suppose that y is our final amount, which is basically 50,000 in this scenario. And t is missing. T is in days, and since it asks how many days. Apart from that, I think we're complete. Let's try to substitute our values. So 50,000 is equal to 100 Euler's times Euler's number raised to 0.2 t. T is missing, so that's what we're trying to find. Divide both sides by 100. Cancel. So e raised to 0.2 t is equal to 50,000 divided by 100, which is 500. And in order to eliminate Euler's number, we multiply ln on both sides. Again, I placed ln here on the right side since it doesn't fit here. Otherwise, it would look awkward. This is awkward, but yeah, I think that's more awkward. Anyways, let's cancel and we get something like this, and ln times 500. Divide both sides with 0.2 in order to leave t alone at the left side of the equation. We end up with something like this. This could actually be the final answer already, but for the sake of exact computation, the exact value in integer form, the answer is 31.0730449. Let's round that off. 31.073, or approximately 31 days. So let's see, how many days does it take until it creates 50,000 hits. So it takes 31 days. Some answers would state that it would take approximately 32 days. I'm not sure, but it's still the same decimal value. So yeah, that's it. Any of these answers could be correct. Let's move to number 3. Dan invests 100,000 pesos in an investment earning 5% per year. How long will it take for his investment to accumulate to 120,000 pesos? And how long will it take to accumulate 150,000 pesos? So let me just show you that we have to have two answers here. One answer would be t sub 1, that corresponds to 120,000 pesos as the final amount, and t sub 2, provided that the A, or the final amount, is 150,000 pesos. So I don't think this problem relates to compound interest. It relates actually more to appreciation. Yeah. Let's just move it here. The formula for appreciation is A is equal to P times the quantity 1 plus R raised to T. Whereas, when we want to write the model equation, we'll just leave A as is, since we have two A values. To make things in general, we'll just model the equation this way. P is said to be 100,000 pesos. That is our initial value, or initial amount. Then 1 plus R. R is 5%, or in other words, 0.05 raised to T. We can actually simplify this, so it's just 1.05. So yeah, that's our model equation. So let's try to solve t sub 1. T sub 1, whereas the final amount is 120,000. So 120,000 is equal to 100,000 times 1.05 raised to t, and divide both sides with 100,000. So we have 1.05 raised to t over 12 over 10, or in other words, 6 over 5. I hope I did that correctly. I simplified it correctly. 120,000 divided by 100,000. Yeah, 6 over 5. So we multiply both sides with log in order to bring down our t, exponent t, or variable exponent. So we have something like t log 1 times 1.05 is equal to log times 6 over 5. Then divide both sides with log 1.05. go right this way. Cancel both sides at the left side. And I'm sorry about that. I hit my calculator at the table. Anyways, log 6 over 5 over log 1.05, we get the answer 3.736850652. So 736850652. Okay, that's correct. Let's round it off. 3.737, or approximately 4. What's the unit? T in years. So our T is approximately 4 years. So it would take 4 years for the investment to accumulate to 120,000 pesos. Let's see when it comes to assuming that the accumulation value would be 150,000 pesos. So here, we do the same process. Only difference is the additional 30,000 pesos. So we have something like this. Divide both sides with 100,000. Cancel. Then 1.05 raised to t over 15 over 10, or in other words 3 over 2. Log, in order to bring down the exponent variable, t log times 1.05 is equal to log 3 over 2. Divide both sides with log times 1.05. Cancel. T is equal to log 3 over 2 over log 1.05. Our answer is 8.310386,223. T is equal to 8.310, or approximately just 8 years. It would take 8 years, about 8 years, almost, not almost, at least 8 years for the investment that earns 5% per year in order to accumulate to 150,000 pesos. So yeah, some answers would state that it would take 9 years. 9 years, 8 years, I don't think there's much of a difference. I think we did the computation accurately. I mean, it's not exactly accurate, but rather precise. So let's move to number 4. Bismuth 210 is an isotope that decays by about 13% each day. What is the half-life of bismuth 210? So, this problem is quite related to decay, literally from the word decays. And we're given a rate since it's 13%. So any value that has a percent symbol, it obviously refers to rate. Therefore, our formula is the exponential decay rate, or in other words, the same formula for depreciation. We are given the rate value, which is 13%, or in other words, 0.13. We're not given values of A and AO. Therefore, we can make use of the formula of something that's related to half-life. A is equal to 0.5 AO. It's over here. So yeah, let's go back. Alright, let's substitute the values now. So A is equal to AO, such that we have 0.5 AO is equal to AO times the quantity 1 minus 0.13 raised to t. We have something like that, and we cancel basically. We end up with something like this. 1 minus 0.13 is 0.87. Of course, we place raised to t. We can't divide both sides with 0.87 because we have a variable exponent. So we put log on both sides instead. And in order to bring down t, our variable exponent. So we have something like this. Divide both sides with log 0.87. Cancel both sides. And so we have log 0.5 over log 0.87, which is basically 4.977286305. Let's round off. We have 4.977, or approximately 5. 5 what? What is our t? T in days. So we have approximately 5 days as its half-life. Let me be honest with you. When it asks about half-life, when the problem asks about half-life, my first conclusion is that t is basically half-life, but it's not always the case. This is not always the case. I'm not sure why. It hasn't been proven yet on my end. I can't really be certain about it yet. But anyways, this is our answer already. This is the half-life. For number 5, cancer cells sometimes increase exponentially. So let's take note of the word exponentially. Maybe this could relate to exponential growth that has the formula A is equal to AO E raised to K T. If a cancerous growth contained 250 cells last month and 320 cells this month, how long will it take for the number of cancer cells to double? Alright, you guys give me a few seconds. Let me arrange my setup. Alright, number 5. So we're given, let's write our given place. Our AO, I suppose, is this one, last month. And this month is 320. How long will it take for the number of cancer cells to double? So it asks about how long, so our T is missing, the time. Alright, this question honestly is quite confusing. I can see that anyone who may have encountered this question for the first time, especially for the first time, it could be difficult. But the problem states a clue that T is 1 month. T is in months. But the question is, it asks for another time. But before we do that though, we don't have the value of constant of proportion, or in other words, our k. So let's solve for it first. So in order to solve that, we are given this value, these values, and we'll be disregarding this value, the 1 month, after solving for k. So I think that is our plan in order to solve this problem. Solving for k, substitute the values. A is 320 equal to 250, Euler's number, raised to our k, which is the missing value, then times 1 month. So divide both sides with 250, or by 250. A raised to k times 1 is equal to 320 over 250, which is basically simplified as 32 over 25. Then multiply both sides with ln to eliminate Euler's number. Cancel, cancel. We have k times 1, or basically k. Then we have ln times 32 over 25. K is equal to ln. I'm sorry. I need a few seconds to type it all in the calculator. 32 over 25. The answer is 0.2469. So let's just round it off up to this kind of fashion, and let's just encircle that. So now that we know k, let's start with the real solving. How long will it take? So the question asks t is equal to what? How long? And provided that the number of cancel cells will have doubled. So A is equal to 2AO. The final amount is doubled, so double the initial, which is basically 500. Since 250 times 2 is 500. We'll be disregarding this value now, as well as this one, when it comes to solving for the actual missing value. We only use these in order to find k. So yeah, let's build up our equation now. 2AO is equal to AO e raised to k t, such that let's just cancel this already. So we are left with 2 is equal to e raised to k. K is 0.247, I think. Oh yeah, 0.247, or in terms of rounding off, this is also 0.247. So please do not confuse about it. Then times t, which is our time. We multiply both sides with ln. So this one is disregarded now. We have 0.247t is equal to ln times 2. Divide both sides with 0.247. And our t is, place the values in the calculator, and we get 2.80626 3889. Right? I'll leave this to you for a while. I need a few seconds to get something. Just ponder what would happen next. I'll be back in a few seconds. Alright, I'm back. Let's proceed. Let's continue. So the next step is we'll be rounding off our value. So t is equal to 2.8063, or basically 806. I'm sorry for that. Or approximately 3 months. almost 3 months. It would take almost 3 months. Oops, where did I go? It would take almost 3 months for the number of cancer cells to double. Let's move to number 6. We're halfway through. The tuition at a university is increasing by 5.2% each year. So I think there's no sign of stopping. I think the rate is constant. So it suggests that we're dealing with a problem related to appreciation. So our formula is A is equal to 0, A is equal to AO times the quantity 1 plus R raised to T. So we're given R, which is 0.052, and yeah, that's it for now. Write a function that models the amount of tuition after T years. For T years, let's just make a model with the available values that are given. So we don't have A, we don't have AO, so we write them as is. But we do have R, so 1 plus 0.052 is 1.052. Then place raised to T. So yeah, that's the model already. And how many years will it take for the tuition to double? So the what's being asked is T. For the tuition to double, so that means A would be twice the AO, or the initial amount, or initial tuition fee. So let's rewrite the appreciation formula. So A, in other words, to AO is equal to AO times the quantity 1 plus, or basically 1.052 raised to T. We cancel AO. And we have something like this. Put log on both sides. We get T log 1.052 is equal to log 2 divided by log times 1.052. Oops. Duplicate. Alright. Cancel. We have T. And at the other side, we have log 2 over log 1.052, which is basically 13.67339904, which is 13.67, or just add 3, approximately 14. What's the unit? Each year. Therefore, T is in years. So it would take 14, almost 14 years for the tuition to double. The tuition fee is appreciating, not depreciating, since it doesn't get old. Let's move on to number 7. A new car costs 1.2 million. There is no specific currency. It depreciates at a rate 15% annually. So there you go. There you have it. Depreciation. It's pretty obvious already. So the formula is A is equal to AO times the quantity A minus R, 1 minus R raised to T. The rate is 0.15 in decimal form. So write an exponential model. We're not given anything else apart from R and the initial value, which is 1.2 million. No currency specifically whatsoever. So we have A, which is equal to 1.2 or just 1,200,000 times the quantity 1 minus 0.15, which is 0.85, then raised to t. This is our exponential model. Alright, let's move on to letter B, solving letter B. How much will the value be of the car be after 10 years? So the question asks for the final value of the car, or how much it is, how much it will be after 10 years, provided t is equal to 10 years. So let's substitute the values in the equation. Let's accumulate what we have so far. We don't know what A is. That's what we're trying to find. For the initial value, it's 1,200,000. 0.85, then raised to 10. So yeah, just use your calculator and you'll get the answer already. Hopefully your teacher, would allow you to use the calculator in order to solve these problems. Otherwise, I don't know what it is. I can't really be sure why some teachers wouldn't allow the use of calculators when it's already becoming in a subjective statement. It's becoming impractical, so to speak. Anyways, back to the lesson. Let's not engage more on that. 236, 249. When it comes to money, of course, we have what we call centavos or cents. It's just rounded off to the nearest hundreds. So we have this. No need to write any currency since there's nothing specified. Right? That's for letter C. At which year? So t is equal to question mark. Will the car be half the original price? So we have to find t, provided that a is equal to AO divided by 2. Or in other words, A is equal to 600,000, half the original. So the original is 1.2 million. Now it's 0.6 million. Or in other words, 600,000. So let's substitute values now. A, or in other words, 600,000 is equal to 1,200,000 times the quantity 1 plus, actually, sorry, it's minus, just write 0.85 raised to t. So again, let's not simplify, let's not multiply them with each other. Let's divide both sides with this number. So cancel, we have 0.85 raised to t over 1 over 2. Put log on both sides. We have t log times 0.85, which is equal to log 1 over 2 times 1 over 2. Divide both sides with log 0.85. And cancel. T is equal to, our numerator is log 1 over 2, and denominator is log 0.85. T is equal to 4.26502428 or T is equal to 4.26265, approximately 4, just 4 at the 4th year. So yeah, that's it. I suppose that's it for number 7. Everything is answered pretty well. Let's go to number 8. The graph below shows the growth of the Mexico City metropolitan area from the year 1970 through the year 2000. 1970, the population of Mexico City was 9.4 million. By 1990, it's 20.2 million. So, um, we do have, let's assume that this one is our AO and this one is our A. But that won't be always, um, especially when we're trying to find something else that is our A. So we can solve, in that sense, we can solve in two ways, assuming that one of these values are going to be are going to act as our AO or our initial amount. So let's go to number A. Find the exponential growth function that models the data. Before that though, let's write our given. For our A, the final amount, let's assume that it's going to be 20.2 million. For AO, that's going to be 9.4 million. Since this is population growth, the trend will be increasing. The populations will always increase under normal circumstances. For T, it's going to be 20 years, assuming that we have these values accordingly, since 1990 minus 1970 is 20. This is the population in 1990. This is the population in 1970. So yeah. What else do we have to enlist? I think that's it. The word problem is by nature focused on population growth. So it's still a part of exponential growth. So yeah, there's no rate given. So I'm pretty confident that this is our formula. For letter A, find the exponential growth function that models the data. A is equal to AO e raised to kt. We can't really be sure. The letter A value is not constant. It can't always be, for instance, 20.2 million. Because later on, we'll be finding values of A that are not the population of the year 1990. Might be confusing at first, but I hope that it would be more understandable later. For AO, it's pretty constant. The value will always be 9.4 million, assuming that you'll be setting your value, your AO, as 9.4 million. Then times Euler's number raised to k times 20. Actually, no. We can't be really specific about the time. T is 20, provided that A is 20.2 million. But we didn't place 20.2 million here, since A, it will not always be associated with the population data in the year 1990. So this is one exponential growth function, assuming that our AO is 9.4 million. The other one would be assuming that the AO, initial amount or initial population, would be 20.2 million. You start from the year 1990. Then, yeah, just write anything else, copy everything else. So you can select either from these two. We have two answers here. We have two solutions here. We have two options to answer here. So for letter B, it asks what the population will be by the year 2010. So A sub 2010 is equal to question mark. So we can solve this problem in two ways, provided two givens. So for given one, we have AO, which is 9.2 million with a time. So 2010 minus, when was the population in Mexico City? 9.2 million in the year 1970. So 2010 minus 1970, which is basically 40 years. What else do we have to know? For solving for K. We don't know what K is yet, so let's better solve it now. So our available values are these. We solve for K using these values. So 20.2 is equal to 9.4 e raised to k times 20. Divide both sides with 9.4. So cancel. E is equal to raised to k20 is equal to 20.2 over 9.4, which is 2.1489317. Or maybe it does look quite complex. Let's just write it as is for now, since we'll be multiplying both sides with ln. So cancel both sides. We have 20k over ln 20.2 over 9.4. Divide both sides with 20. K is equal to ln 20.2 over 9.4 divided by 20. So our K, or constant of proportion, is 0.03824864576. K is equal to 0.0382. So yeah, there's no unit, just fresh like that. Let's continue with letter B. So provided that, of course, K will always be 0.0382, as well as for the other way of solving it. Let's just copy paste this. The other given would be 20.2 million, such that 2010 minus 1990 is why is this not working? Okay, 20 years. So yeah, let's try to solve using technique number 1. So substitute the values now. A 2010 is equal to 9.2 million e raised to 0.0382 times 40. So place that in the calculator. 9.2 Euler's number raised to 0.0382 times 40. The answer is 42.40233,723. Round that off. 42.4023. Or just approximately hang on. Approximately 42 million. So yeah, I think that's it. It could be acceptable if the answer would be approximately 43 million. Let's try the other way. Let's assemble our given. So a sub 2010, that's what we're trying to find. For a sub o, we have 20.2. Then, alright, Euler's number, I almost forgot. Then raised to 0.0382 times 20. 20.2 Euler's number raised to 0.0382 times 20. A sub 2010 is equal to 43.36629,838. Let's just copy this. 43.366, or approximately just 43 million. So around that number, that's going to be the population by 2010 in approximation. As you can see, the decimals decimals are prone to inaccuracy, so especially if you round them off. That's our conclusion. For letter C, by what year? So the question is t is equal to question mark, provided that a is equal to 40 million. So by what year would the population of Mexico City reach 40 million? Let's see. There are actually two ways to solve this, but let's stick to one. Let's try to make this simplified as much as possible. We'll stick to this one, provided that a sub o is equal to 9.4 million, and our t would be based on the year minus 1970. Actually, no. Just note that 9.4 million, this was the population of Mexico City back in the year 1970. So I think that's everything that you have to know. Let's try to substitute now. 40 is equal to 9.4 Euler's number raised to k. K is what? 0.0382. Raised, actually no, times t. Divide both sides with 9.4. E raised to 0.0382 t is equal to 40 over 9.4, which is, let's just keep it as a fraction. Multiply both sides with ln. So we end up with something like this. Divide both sides with 0.0382, 0.0382. Oops, I'm sorry about that. Cancel. T is equal to ln times 40 over 9.4 over 0.0382. T is equal to 37.91020,327. T is equal to 37.910, or approximately 38. What's the unit of T? In years. So approximately 38 years. the population of Mexico City will reach 40 million after 38 years, provided that the population starts from the year 1970, since our initial population is based on the status of 1970 population, 9.4 million people. So yeah, that's it, I suppose, um for number 8. There is also another way to solve this, provided that AO is equal to 20.2 million. The given here is the same, but this time we base our initial population on the year 1990. It's a long way ahead, but I suppose this could be my assignment for you. Do this yourself. Yeah, do it yourself. Let's go for number 9. A certain radioactive isotope sample decays annually at a rate of 24%. So there is still a rate, therefore our decay formula would be the depreciation one, not the radiation decay or radioactive decay. So R is equal to 0.24. The half-life is missing. So therefore, for the half-life, A is equal to 0.5 AO. Let's take note of that. Substitute the values now. 0.5 AO is equal to AO times the quantity 1 minus 0.24, which is, in other words, 0.76, then raised to t. Cancel both sides. We end up with something like this. Put log on both sides to bring down the variable exponent. We have t log times 0.76, which is equal to log times 0.5. Divide both sides with log 0.76. There you go. T is equal to log 0.5 over log 0.76. We have 2.52570741. In other words, T is equal to 2.52 or 526, or approximately 3 years. The half-life of this radioactive isotope is 3 years, provided an annual provided the rate of 24% decaying annually. Let's go to number 10. A certain machine, so we're trying to solve a problem related to depreciation. So for our formula, it's A is equal to AO times the quantity 1 minus R raised to T. So given, the initial amount is 450,000 and the rate is 0.15. So yeah, let's present a model exponential equation. A is equal to 450,000 because the AO will always be 450,000, the initial amount. Then times the quantity 1 minus R, or 1 minus 0.15, which is 0.85. Then put a raised to t. This is our model exponential equation. Let's move to letter B. How long will it take for the value to depreciate to half the original cost? So t is equal to question mark, depreciate half the original cost, Original cost is 450,000. So the letter A is AO over 2, which is basically 450,000 divided by 2, 225,000. So A is equal to never mind. My brain's a little malfunctioning at the moment. 225,000 is equal to 450,000 times 0.85 raised to t. We're solving for t. Divide both sides with 450,000. Then 0.85 raised to t is equal to 1 over 2. Put log on both sides. Then t log times 0.85 is equal to log times 1 over 2. Divide both sides with log times 0.85. So cancel. T is equal to log times 1 over 2 over log times 0.85, which is 4.265024282. T is equal to 4.265, or approximately 4. What's the unit? Years. T in years. So it would take almost, more than 4 years, around more than 4 years, for the machine to depreciate to half the original cost. For number 11, a bacteria culture starts with 1,000 bacteria and the number doubles every 40 minutes. Right, this question might be quite tricky. There's no mentioned, hang on, doubles, so I think this question relates to exponential growth. Therefore, our formula is A is equal to AO e raised to KT. So initial amount is 1,000 bacteria. The number doubles every 40 minutes. So in order to solve for K, we're not given much other details apart from number doubles every 40 minutes. We could make use of the 40 minutes. In order to solve for K, it's basically 1 hour over 40 minutes, the given 40 minutes here, which is basically 3 over 2. So yeah, that's our K. K is 3 over 2. For Euler's number, I suppose that's going to be replaced with times 2. It says here number doubles. You might ask why, and you might ask how that is justified. I can't really be sure also. That was also my question when I first encountered the answer key, the solution key on this problem. I couldn't solve it myself. So I looked upon the answer to this problem and this came about. For letter K, it's basically 3 over 2 and times t. So yeah, that's it. For the formula, we don't have a final value for A, but we do have for initial amount, it's 1,000, then times 2 raised to 3 over 2, which is basically 1.5 in other words. So raised to 1.5 times t. This is our formula. Right, for letter B, find the number of bacteria provided t is equal to 1r. So in that case, A is equal to 1,000 times 2 raised to 1.5 times 1. A is equal to, hang on, 2000 raised to 1.5 times 1. Oops, sorry. I did something that's not allowed. I did not follow the PEMDAS rule in the calculator. Therefore, I got the wrong answer. So, just write this, literally write that expression in the side calculator, and you get 2828.427125. Because what we're trying to find is the number of bacteria. It's basically just like number of coins. So you cannot say 5.2 coins. You can just round it off, basically say 5 coins. So that kind of concept goes the same with this. A is equal to 2828 bacteria. That's it. Regardless of the decimal number, you can round it off if it's 5 or above, but apart from that, you cut the decimal part. You cut this out, leave this behind. For letter C, after how many hours will there be 50,000 bacteria? So the question is T is equal to question mark, provided that A is equal to 50,000 bacteria. So same old, same old. Let's just substitute the value. So 50,000 is equal to 1,000 times 2 raised to 1.5 times T. So this is our equation. Divide both sides with 1,000. 2 raised to 1.5 T is equal to 50,000 divided by 1,000, which is 50. So put log on both sides. We get 1.5T log times 2 is equal to log times 50. Divide both sides with log 2. So log 50 over log 2. I think you could still just keep relax space there. Let's just move it here. There we go. So log 50 over log 2, divide both sides with 1.5. T is equal to 3.762570793. T is equal to 3.762 or 763, approximately 4 hours, I think. Yeah. There will be 50,000 bacteria in 4 hours. Almost 4 hours. For number 12, the last question, finally. Carl bought a new sports car for 20 million pesos. It depreciates annually by 20%. So let's write the given. So R is equal to 0.20. Initial amount. Alright, depreciation. The formula is this one. Our initial amount is 20 million. Okay. Write a model exponential equation representing the amount of the current years. A, place it as is, 20 million. Then times the quantity 1 minus 0.20, which is basically 0.80, raised to t. So this is the exponential equation model. So yeah, let's move on to letter B. What will be the car's value after 5 years? So given t is equal to 5, a is equal to how much? A is equal to 20 million times 0.80 raised to 5. Place that value in the calculator and the answer will be 6,553,600 pesos. So yeah, that's it. How long will the value of the car be half of its original value? So how long? T is equal to question mark, provided that the current value of the car will be half of its original value. So AO divided by 2, which is basically 10 million. So in that case, 10 million is equal to 20 million. I'm sorry, 25 million. I think that's the initial. Never mind. It's 20 million. Then times 0.80 raised to t. Okay, divide both sides with 20. I'll just place m as million. 20 m. Okay, so 0.80 raised to t is equal to 1 over 2. Log, put log on both sides. T log times 0.80 is equal to log times 1 over 2. Divide both sides with log 0.80. T is equal to log 1 over 2 over log 0.80. T is equal to 3.106287372. T is equal to 3.106, approximately 3 years. The value of the car will be half its original value by about 3 years. So yeah, let's check our answers from 1 to 12 just to make sure. Alright, for number 1, 12 years, about 12 years, or 11.651, okay, correct. About 32 days, 31 days, oops, why do we keep pressing that? Anyways, number 3, correct. Number 4, correct. About 3 months, 2.806, okay. Number 6, okay. Number 8, yeah, any of the two. As for this part, I'm still not going to answer it. It's up to you. Just follow the same process and you'll be fine. The answer would basically be t is equal to 17.979, or approximately 18 years, provided that we have this given. Of course, it would take 18 years for the population to be 40 million, starting from the year 1990. I hope it makes sense, as well as this one. It would take 38 years for the population to be 40 million, starting from the year 1970. So yeah. Let's move to number 9. 3 years, 2.526, correct. 450,000, 0.85 t, correct. 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 Okay, I think that's all for this video. We've solved a lot of practice questions in this video. I hope you've learned something. I hope this video has been really helpful, at least helpful to some extent. You may not be able to finish this entire video for your study, but yeah, if you made it this far, thank you so much. Thank you for watching, and I'll see you next time.